Applications of Doppler effect. The illustration shown here will help you understand the Doppler effect. I'm sure you would have heard an ambulance speeding past you. That is, the pitch of the siren increases as the ambulance approaches you, and the pitch decreases when the ambulance moves away from you. There is a similar apparent change in the pitch of the sound heard when the source of sound is at rest and the listener moves towards or away from the source. The change in pitch is due to a shift in the frequency of the sound waves. Based on these observations, an Australian physicist and mathematician J.C. Doppler proposed the Doppler effect in 1842. According to the Doppler effect, the apparent change in wavelength of sound or light is due to the motion of the source, observer, or both. Doppler effect is observed in light also. Suppose a star recedes from Earth, then the frequency of the light emitted by the star decreases or wavelength increases. Thus, the spectral lines are shifted towards the red end of the spectrum. This is called redshift. Similarly, when a star moves towards the Earth, the spectral lines shift towards the blue end of the spectrum. Applications of Doppler effect. To find the velocity of a speeding car. Let us see how a traffic police catches speeding motorists. Short waves emitted from an observation center are directed towards the speeding vehicle. These waves are reflected by the car to the observation center. By calculating the shift in the wavelength, the velocity of the speeding car can be determined. To determine the depth of oceans, we can apply the Doppler's effect for estimating the depth of the oceans. For this, we make use of sonar. A transmitter from a ship transmits sound waves towards the ocean floor. These waves are then reflected by the ocean floor and are received by the receiver. Note the time taken by the waves to come back to the source. Now we can estimate the depth of the ocean by using the formula d is equal to v into t by 2, where v is the velocity of sound waves and t is the time taken. To calculate the speed of astronomical bodies, the Doppler effect of light can be used to measure the speed of stars and galaxies. The spectrum of light coming from the planets and stars are photographed over a long period. By observing the Doppler shift, one can conclude whether they are moving towards or away from the Earth. To study Saturn's rings. Concentric rings surround the planet Saturn. These rings reflect light and are not self-luminous. The Doppler shift of light reveals that the rings are not continuous, but they consist of many particles.